Welcome to this PragmaDev Tester presentation and demonstration. We will first go through a general presentation of TTCN3, the underlying testing technology, and then move to a tool demonstration on a simple example. PragmaDev Tester is one of the four parts of PragmaDev Studio. PragmaDev Specifier helps system engineers to unambiguously specify the functionalities of a system and find the best architecture. PragmaDev Developer helps software designers to write maintainable and self-documented code thanks to its graphical description. PragmaDev Tracer is a standalone tool to write scenarios, to generate traces, and to verify dynamic properties. Finally, PragmaDev Tester helps testers to write validation and integration tests with an abstract dedicated language. It can be used to test abstract specification as well as the implementation of a system. PragmaDev Tester is based on TTCN3 International Standard. TTCN3 stands for Testing and Test Control Notation. It is written by ETSI and standardized by ITU. TTCN3 is a textual language that includes high-level services such as messages, procedures, timers, and parallel execution. TTCN3 also includes its own data types, the concept of template in order to verify an information in one statement, a test case organization, and the concept of verdict. The system to be tested is called the system under test, SUT. A test case is organized in a control part that controls the test execution, a master test component, and some optional parallel test components. The test case interacts with the SUT through the system interface that defines a set of ports. A port can be asynchronous, like a message, or synchronous, like a function call. Once the test cases are written, in order to execute them against the SUT, the system interface needs to be implemented. Let's have a look at the architecture of the system interface. First, we have the TTCN3 part. Second, the SUT, and finally, the system interface in between. The SUT has its own internal architecture, possibly with threads and message queues. In the test case, a TTCN3 send instruction will actually send a message to an interface agent. The agent calls the macro corresponding to the port through which the TTCN message is sent. The user can fully customize the macros. For example, it can use a send message service to the SUT. On the other way around, information coming from the SUT is put in a message queue. Each test component is mapped to one of these queues to receive information. To ease integration, the generated code defines macros to easily write in the queues. Let's now see how that works in the tool. Let's now start PragmaDev Studio. We will open one of the test examples coming with the tool. It's a simple send request waiting for an answer. Let's have a look at the TTCN file. Two messages are defined as TTCN records. One is called mRequest and the other one mAnswer. Each message has one parameter. The port type is defined with mRequest message going out and the mAnswer message coming in. The component that uses the previous port type is defined. Two templates are defining the values of the parameters of the messages. 42 for the mRequest, 43 for the mAnswer. Here comes our test case. It will run on our previously defined component. The test case will start a timer and send a request. Please note the name of the template is actually used to send the request. For the answer, an alternative is created. Either the system replies the right answer, or another answer, or the timer goes off, meaning the SUT did not reply in time. Let's have a look at how the adaptation to the SUT is done. First, let us see what the SUT does. In our example, the SUT is just a function that sends back a message through the sendAnswerMessageToEnv function. The sendAnswerMessageToEnv C function is defined in this file. Let's see how the interface between the test case and the SUT is done. The generated code will call the C macro rtds_ttcn send message when sending through the SUT port. In that case, the user has decided to call the handle request message C function in the macro. In our example, this function is actually part of the SUT. Let's now run our simple test case and see how it behaves. The test case is being compiled with GCC, and once it's done, it is started with the GDB debugger, which is connected to our interface. Let's start a trace to see what happens in the test case. Let's now run the system event by event. First, the control part is started. Then the system interface with the SUT is created. The only test case of our example is now created. The test case is now started. Before we go further, we will set a breakpoint in the test case. And now, let's resume the test case. The breakpoint is hit and the debugger stops. We can see where we stopped in the TTCN. We can step in the test case at TTCN level. The debugger will automatically step in the C code to a new line in the test case. It is also possible to step into the generated C code. Actually, from any line in the generated C code, it is possible to jump back to the TTCN source. Let's now run the test case until the end. The verdict is fail because the timer went off before the answer was received. This is because of the step-by-step execution we did. We should have used the discrete time mode instead of the real-time mode. Let's now run the test case without any debugger to see how that would execute on a real tester. The code is generated, then compiled. The executable file will be situated where the make was done, here. This is the default interface of the generated code. As you can see, the available modules are listed. We will run the control part. We can see the final verdict is pass. Okay, this is the end of this simple TTCN demonstration. Thank you for watching. PragmaDev Studio is free to download and does not require any license for small systems. So please, give it a try.